Good day. I am Wynand Steyn. I'm the Dean of the Faculty of Engineering, Built Environment and Information Technology at the University of Pretoria. But today I want to focus on a slightly different aspect of my life. I am also a civil engineer. A civil engineer is the type of engineer that focuses mainly on infrastructure. You will typically know it as the engineers that looks at development of large buildings and bridges, roads, waterworks, look at foundations for large buildings and so on. And that's broadly speaking what civil engineers are doing. So I initially trained as a civil engineer, done my undergraduate studies here at the University of Pretoria, and then I've focused and specialized in my postgraduate studies more in the area of road pavement engineering. So a road pavement is typically that part that you see when you travel somewhere. You will just see a surfacing. But for the road pavement engineer, it's actually much more complex than that, because it consists of all the different layers of materials that you need to put together to construct this road pavement structure. To make sure that you've got the correct materials combined in certain fractions and so on, to ensure that this road that you construct can do various things. It can carry the loads of the vehicles that travel on it, and it can do this under all different environmental conditions. Because the difficult part for a road is it does not serve its life in a building. The road is out there, and by day, maybe the sun is shining on it and you've got hot conditions, and then you've got some rain coming down and it cools down and it becomes wet, and the materials changes its properties, and the whole structure actually responds differently to the type of loads that you put onto there. So that's the aspect that I specialized on, is specifically the road materials, how we combine them, and how vehicles that travel on the road are interacting with the road itself. Because it's not like just the vehicle travel on the road and it's a one-way type of traffic. No. The road affects how the vehicle travels, and the vehicle again determines how the road deteriorates. So let's start at that point, and then we go deeper down into the road itself. All of us know vehicles, cars, trucks, buses, whatever we are used to traveling with. Now, the mere fact that you've got a vehicle means that you've got something with a mass, and that can be something light like a bicycle, or it can go to an abnormal truck, and everything in between. And the mass of that vehicle is conveyed to the road pavement through its tires. That's the only contact point that you've got to actually get this large mass through to the road, and that's where it actually makes the contact with each other. So as your vehicle drives on the road at different speeds, those speeds also affects how this mass is converted to the road itself. A vehicle does not only have a constant mass. All of us know you are traveling in a vehicle and you can feel that there is some additional movement in this vehicle. And that's partly due to the type of suspension that it's got, the type of tires, the speed at which you are traveling, the makeup of the vehicle itself. But that means that the load that this vehicle puts on the road is not a constant value. It changes all the time as you travel. And these changing loads then obviously has got an effect on how the road reacts. Because if you apply a higher load, the road will deteriorate in a different way than when you apply a lighter load. So the interaction means that as the roads start to change its profile due to these different loads, the vehicle also reacts to this again. So it's a constant interaction between whichever vehicle traveling on your road and how they affect each other. And what's quite important in this regard is that obviously then whatever you transport in your vehicle gets affected by this interaction. So you will know if you are a driver or a passenger in a vehicle, you will know that some roads are more bumpy than others. That's how one can describe what we normally call the riding quality of the road. And the more bumpy the road is, the less safe you feel at higher speeds, and the more you feel that you are moving around in that vehicle. and sometimes it's uncomfortable. So why is that important? For you as a passenger, it's uncomfortable and you get tired of this constant type of movement. But just think for a moment about the cargo that you are transporting. The cargo can be many things. It can be things like aggregate or cement or something that you've got in a big truck, but it can also be things like food. And very specifically, because that's something that I've done quite a bit of work on, is how does this condition of the road and the interaction between the road and the vehicle actually affect tomatoes, avocados, and similar type of produce when it is transported from the field to the market. Because it doesn't help to have perfect tomatoes on a farm and you don't have them on the market. People come and buy it at the market and the shop. So we have developed various types of sensors. That's again where it's important to know your colleagues in other disciplines, because a civil engineer does not typically understand all the intricacies of sensors, and that's why we talk to our electronic engineering colleagues and the data colleagues and so on. So we developed this smart tomato and a smart avocado, which is a 3D printed shell with the sensors on the inside, because we want to listen to what the tomato and the avocado and various other types of fruits and vegetables and produce actually tells us about their experience while traveling on a certain road. How do you see the outcome of this transportation? You go to the shop and you want to buy a tomato and you see that it's slightly bruised. And because the one is bruised and the other one not, you want to buy the one that's not bruised. That bruising can partially be due to the transportation conditions. Because if you put a perfect tomato on a truck, but the road is such that the tomato is bumping up and down the whole time as it is being transported, it will start to bruise. And the outcome of that is that unfortunately, people will either not buy the bruised tomato or they would not be willing to pay a good price for the bruised tomato. What does that mean? It means the farmer who produced a perfect tomato gets less money for the tomatoes, not because they did a bad job, but because somebody did not maintain the road in a good condition. So that aspect of vehicle-pavement interaction is extremely interesting, and it affects our day-to-day lives. As a civil engineer, I can't do much about the growing of the tomatoes. But what I can do is I can firstly design a road to actually do its job as well as possible. And then through the life of that road, which is typically for our road designs 20 to 40, 50 years, I need to make sure that I maintain that road in as good a condition as possible. Because roads are like any other infrastructure. If you use it, it will start to deteriorate. Because we apply stresses and loads and strains and things on it, it will start to deteriorate. It does not have to fail. If I've got a good maintenance and rehabilitation plan, it means that I will observe this road infrastructure continuously. And we've got beautiful systems and sensors and tracks and photographic ways of doing this. And at the moment that I see that the deterioration is getting too much, I will come and I will do certain types of maintenance. That may mean that I come and I spray something on the road to fill some of the micro cracks where water can enter. It may mean that I put a thin overlay on this road to make sure that the riding quality is good again, so that you don't have a bumpy ride. And various other ways of continuously looking after this infrastructure to make sure that whether it's a tomato or an avocado or a person or a patient or whatever is being transported on this road is actually having the best, smoothest transportation experience that they can have. By doing that, we are not only keeping the tomatoes in a good condition, but it has been measured and proven that the better the riding quality of your road, the lower your fuel consumption. So it actually costs you less to transport something on a good road than on a bad road. So it actually makes sense to maintain your road infrastructure as well as you can do that. Now, if you look at all of this and you say, good, how do I maintain the road? What are the materials that goes into my road? must be simple because it's just this blacktop surface and that's it. Actually much more complicated and real fun to look at the behavior of the different types of materials that we use in road construction and maintenance. There's 2 or 3 main type of materials, if I sort of put it together like that we use in road construction and in maintenance. The first one is aggregate. Aggregate, soil, gravel, you can name it different types of things, but that's when you dig a big hole or you break big rocks into smaller parts, that will be your aggregate. And that's typically the strong part of your road and the bulk of the material. And we will typically use that for the lower layers of our road structure. Carries a lot of the load. We test these materials using different types of tests to make sure that it's strong enough, that it doesn't deteriorate too quickly. And then we put it together in different layers. We compact it to as good a density as possible, and that will be our lower pavement layers. Now, what's important to understand about granular materials or soils is that your biggest enemy to them is water. All of you will know that if you've got a dry soil that appears to be pretty strong, if I started to add water to that, at some stage it becomes mud, and mud is not strong. And that's sort of the 2 extremes of what can happen in your road. Hopefully you don't get to the mud stage, but as you get water into your aggregate or your aggregate type of material, it will typically deteriorate in strength. Therefore, we need to protect these materials against water. How do we do that? In simple terms, for the majority of the roads that you will see that we call flexible surfacings, we will use, let me call it a blacktop surfacing. The reason why I call it a blacktop surfacing is this is what you will see when you drive on it. It will be this black, dark gray type of surfacing. That's all that you can see of the road. What is that material? That material is again a combination of aggregate, small pieces of rock, that we mix typically with bitumen, not tar. Tar is very similar to bitumen, but it's got a totally different story of where it originates from. And pretty much all over the world, we currently use bitumen. Now, the story of bitumen is actually quite important because then you start to understand also why global politics affect the cost of your road. So bitumen is a byproduct from the whole crude oil process. You extract crude oil, and through various refining processes, you take out various fractions, and that becomes your fuel. And typically the heavier part is what we call bitumen. Now, firstly, just looking at a bit about the economics and the global politics about bitumen, is that you will know that there are certain areas in the world where our crude oil originates from. And the problem is you will typically see it in fuel prices. If you've got global unrest or global political challenges, you will see that the crude oil price increases and your fuel price increase, and that's where the normal consumer will focus on. However, if you are a road engineer, it's not only the fuel that goes up, but once you've got those types of challenges and the crude oil price increases, the price of your bitumen also increases because it's got the same basic original form of crude oil. So crude oil goes up, fuel goes up, your bitumen cost goes up. So the cost of your road can be directly affected by global politics. Now let's say we get our bitumen, and we've got various sources from where we get it in South Africa. It's currently all imported. The properties of the different types of crude oils that's been used to manufacture the bitumen affect how this bitumen reacts to different types of stresses in its life. Then it's important to understand a term that we call viscoelasticity. So viscoelasticity or viscosity of a material is an indication of how easy it flows or does not flow. So the easiest example is to look at something like honey. And we know that if you take honey and you put it in the fridge, becomes a pretty stiff material, and you can take a container of honey out of the fridge and turn it around, and it will not really flow out of the container, or over a long time it will slowly flow out. If you take that same container of honey and you now put it in the microwave oven for 5 minutes, and you take it out very carefully, it will suddenly have the consistency almost of water. So it flows quite easy, and it's the same material. So viscoelastic materials like bitumen is temperature sensitive, which means that at different temperatures, it will react differently. So that's a very important aspect in terms of constructing roads and also maintaining them. If I take this high viscosity material, the bitumen, in its cold form, think about the honey, and I try to mix that with small pieces of aggregate, it's extremely difficult because you cannot mix it. But if I just increase the temperature, suddenly it flows much easier. I can mix it with the aggregate, and I can place it as I would like it to have the shape, the thickness, everything on my road, and then it cools down to normal temperatures, and then I've got a pretty stiff surfacing layer on that road. And now under normal temperatures, the viscoelastic properties of that bitumen causes it to actually being able to carry the loads that we put onto the road. The challenge is when you've got increases in temperature. If your daytime temperatures goes very high, and you would have seen this in the news during summer, every now and then, if we've got a very hot summer, people complain about the roads because it becomes sticky. And sometimes it actually starts to push away when you put heavy loads onto that. It's the same principle. It's the viscoelasticity of the bitumen. So what is the challenge for the roads engineer? It's to source the types of bitumen and then to change the properties in various processes when we prepare the bitumen to actually be sensitive to the temperature ranges where I use that bitumen. So if I build a road in an area where the temperatures, daytime temperatures gets very hot, I will need a different type of bitumen than in an area where the daytime temperatures are not that high. Because the two of them will both be a sticky black material, but they will react differently to these temperatures. And that's a major part of our research in the road pavement area. Because if you now look at global politics on the one side, the supply of crude oil often is not as much as we would like it to be. But another very interesting aspect that people often miss is the whole move towards electric vehicles. So as I move from a normal fuel internal combustion vehicle to an electrical vehicle, I don't need fuel anymore for that specific vehicle. Now, I said earlier, my bitumen also comes from the same crude oil from which I get my fuel. So if the demand for fuel starts to drop, because I need less fuel for my electrical vehicles that doesn't use it at all, it also means that the supply of my crude oil and my bitumen starts to decrease. So changing from internal combustion vehicles to electrical vehicles is a good thing, various ways. But as road pavement engineers, it's a major research challenge to us to make sure how in future we will need to make use of less available bitumen or other types of material that we can stick that aggregate together to make this blacktop surfacing that we are used for many years to use on top of our roads. So it's a major research field to see how we can use the available bitumen in a better way, how we can maintain the roads that we've got for longer durations, because the moment they break apart, if we did not do our maintenance, we often lose that asphalt, and then we need new bitumen to be brought in, and the market is getting smaller and smaller. And we need to look at alternative ways of developing this actual glue part, the viscoelastic material that we put all of the aggregate together with. So that's one aspect of not only local research, but international research, where we collaborate with various countries in the world to also look at how they solve this problem. The other problem in terms of materials is the type of aggregate and soil that we use for the lower materials. Typically, for many years, We used very high quality types of rock that we broke down, very strong rock. The problem with them is they cost us quite a bit of money because we have to source the rock, we have to crush the rock, we have to transport the rock. And a major move over the last number of years in terms of these types of aggregates and soils is to see to what extent can we use local in situ materials, that we do not have to transport those materials from far away. We can actually get it locally, and that saves us a huge lot of money in terms of our construction costs and procedures. So as I said, people need to travel. People need to move between point A and point B for whatever reason. And for that, we need the vehicles, but we also need the road structure. And we need to construct it. We need to maintain it. We need to make sure that it's in the best condition that it can be. And we've got the materials and the techniques and the knowledge to actually do that. We just have to keep on doing it. And by doing that, we allow people to continue with their lives without being concerned about the road structure all the time. That's my concern. That should not be your concern as the road user. So if you are really interested in this, you may have many questions like, okay, but is there really a job for me? What will happen in 20 years' time? Am I only going to work here on my own, or are there other people that's interested in this? And how do I actually get to this point? So the first important part is there's a job for sure. If you look at the number of roads in a country like South Africa, we've got around 750,000 kilometers of road. It's a huge network, and that network, as I said earlier, needs to be continuously maintained. You cannot just leave it like that and hope that it will be good. A road is not like a tree. You plant it and the tree looks after itself and it grows and it keeps in a good condition. It still needs water and air and so on. A road needs to be maintained. You need to look after it. So there's a long-term job for you, even though you may not construct new roads, but you may be responsible to make sure that those important roads, the ones between my house and my job, between my house and the hospital and the school and the shop, whatever the case may be, that they are actually in a good condition. And for that, we need engineers to be the contractors, to be the consultants, to be the designers, to fulfill all those specific roles. And talking about South Africa, it's part of the whole continent. If you look at the road network as we travel up and down into the rest of Africa, we've got exactly the same challenge. If we want the economies to grow, we need good road infrastructure because we need to transport people and the goods to make the economy grow. So it's extremely important to understand that the fact that we've got a large road network doesn't mean that there's no job for new road engineers. There are many challenges. There are many opportunities. And it also allows you to work much wider than your town or your area or even your country. Because in a lot of the research that we are doing, we've got international networks. Because people have got the same challenges. Vehicles are not only traveling on roads in South Africa, it's also happening in China and in the US and in Europe and Australia and wherever you go to. And that's why we've got strong networks with colleagues in those countries, in their universities and their research institutions, to learn from each other and to co-develop so that we don't have to each and every one repeat the same type of developments, but that we learn from each other and we build on top of that and make sure that together we actually provide humanity with the best roads that all of us can do in that regard. So you will actually have a very interesting life being a civil engineer focusing on road infrastructure. You will have challenges for many years to come. And how do you get in? How do you get started? How do you develop this knowledge about roads? So, unfortunately, if you don't like it, you need mathematics. You always need mathematics, all your engineering disciplines, because that's a basic language that we use to communicate, to understand, to check, to calculate, to design. Without mathematics, one cannot get anywhere. But let's assume you've got mathematics and you've got the interest in that. You need a qualification in typically civil engineering. Although it's quite interesting, if you look at the material side, there's many people that's got different qualifications where they only focus on a certain type of material. But that type of initial training and education in engineering or material science is important. But then it really becomes interesting, because then your inquisitiveness kicks in. That's when you start to ask the questions, especially if you are interested in the research part, in the developing new material. That's where you need to stand on a road and look at the road and start to ask questions about, what do you see? Looking at the road and say, well, I see some cracking on this road and I don't see it on another road. Why does the cracking happen over here? Well, I see that this road deteriorates quicker than another road. Ask the question, why is this the case? Is it different materials? Is it a different environment? Is it different types of traffic? Why does it change like that? And that's probably the most important part for you and your development as a researcher, is to be able to ask questions and look for answers that other people may have missed, because they looked at the problem in a different way. That's what allows you to drive on a road and not only look at the environment around you, but also at the road itself, and trying to understand, what's the story of this road? Why does this road deteriorate in a certain way? Why does it carry the traffic in a way that's different than something that looks exactly the same, but that's maybe just in a wetter area? So that's very important for your development as a researcher, is to start to be very inquisitive about, why does certain things happen. So in this research career, it is very important to be inquisitive about what happens on the road, to be able to look at a road, read the story of a road, listen to a road, understand how it reacts to different things that affects it, but then also be inquisitive towards other disciplines. Talk to your colleagues in chemistry, chemical engineering. Talk to the ones in geology. Understand where the crude oil originates from, so that you understand what the properties differences are between bitumen A and bitumen B and bitumen C, which for the untrained eye all are the same viscous black liquid. But for the trained eye that understands that there are chemical differences between them, understand what type of questions to ask, what type of tests to do to understand what you are interested in. So in this process, we are working with researchers internationally. We've done quite a bit of work with the California Department of Transportation, with University of Illinois, with universities in the UK, also Australia and New Zealand, because a lot of their materials and traffic are very similar to us. Also, if you look at other countries in Africa, we've recently worked very strongly with the departments in Tanzania, who look for a different way, an improved way, a modernized way of designing their roads and maintaining their roads. And in that regard, you start to understand that your international colleagues are a very important part of how you do your job. Some of the other relationships that we've got is with the Shanghai University in China. You may think totally different country, totally different language, but in the end, bitumen and soil doesn't know the language. It reacts to stresses and strains in certain ways. And that's the challenge for you, developing in this area a research career or a consulting career or a contractor career, is to understand your materials, listen to your materials, look for the story that comes from them, because that shows you the highlights, the cherries that you need to pick to understand the picture better, to develop the new knowledge, so that you can take that knowledge and then transfer it to students, which is quite important for the next generation, but also go and use it on a day-to-day basis on our roads. So it's important, whatever aspect you are looking at, whether you are interested in transporting people or produce, tomatoes, infrastructure, whatever the case may be, that you are in a position to use the best knowledge and understanding from your materials and the road structure and your vehicle pavement interaction on how to make sure that it's a most economical and sustainable transportation option for that specific commodity. So I hope it gives you some glimpse in terms of a journey that for me is running for 35 odd years already in understanding the microchemical part of materials to get from there to a huge road network, and really appreciate that it's not just a strip of road sitting over there. It's a lot of engineering, it's a lot of science, it's a lot of beauty to see how it actually does its job. So I hope this explanation of my research career and what I'm really interested in helps you to understand how EBIT makes today matter for humanity and societies.